Hey, how's you going, boys? Mike here. Welcome back to Grampie's workshop. The project today is we have a small engine on my wood splitter and similar to the ones on my generator. And I needed a new coil for it, ignition coil. So when I went on Amazon to order a coil, I found one coil that was $41, which is expensive, I think, but a lot cheaper than you can buy them in shops around town here. So $41 for one of them. And I found another one for $13.82. So what's the difference, I asked. So this is the $13 one, $14 one we'll call it. That's the $14 one. And this is the $41 one. So what I'm going to do is I just want to check the two of them static tests and checks and measurements, just to see if there's any real physical differences outstanding on them. See what we can discover. Here we go. The $41 coil. Okay, so first check I'm going to make is the length of the high tension wire on it. And I'm going to go from the edge of the insulator here on the connector back up to the edge of the insulator where it goes into the coil. And this is just a rough measurement. Doesn't have to be very precise really. That's 11 inches. So 11 inches on the $41 one, right? Another thing I want to measure is the length of the grounding wire that connects to the kill switch. I'm going to go just from there right to there, and that's 20 inches. Alright, now I want to check the thickness of the cores. So I have my verniers here, and they measure 11.9 mil. Now another important measurement, of course, is the distance between the two mounting holes here. So we'll measure that. And I'll go center to center, and it's just eyeballing the center lines here. I expect this is going to be okay, this measurement. 67.1. Okay, and now we're going to measure ohms. See if we get any kind of reading on them here. So my meter zeros. Let's put that one in there. No, it's saying it's open there. So I think that test of the continuity of the coil is maybe not good, because it's a solid state device in here, and I think there's probably some switching taking place in there. Some solid state switching. So I don't know what other tests I can do on that. So I'm just going to put this one aside here. And that's going to be it for the $41 one. Now for the $14 one. This is the $14 one. So if I can remember that this is the $14 one in my right hand, and the more expensive one. First of all, I just noticed that the back on the cheaper coil here is wider than that, than the back on the more expensive coil, if that means anything. It looks like the connector on the cheaper coil is of less quality than the connector on the more expensive coil. But the high tension wire looks the same. It has the double insulating jacket on it. It has the elongated plug connectors, because as you know, on those Hondas it's hard to reach in and get the plug wire, and the plug connectors look to be identical. The coil, physically the coil, let me just see, I didn't measure that, but this coil measures 28.3, and the physical dimension on this coil is 30.6, so the cheaper coil is fatter. What does that mean? Not really sure. Anyway, so first off, looking at them, they look identical. So let's measure this high tension wire from the spark plug insulator to the coil insulator. That says 10.5. Ground wire doesn't look nearly as long. The ground wire is only 15 inches in thickness. .1, and the center to center. 67.1. Okay, now let's see if I can get some resistance reading here. No. What I found was, if I show you this, if you can see it, I'm not sure, but the length of the HT wire, the more expensive coil was 11 inches, the cheaper one was 10.5. That could be an issue, but a ½ inch I don't think is going to matter much. The ground wire, the expensive coil was 20 inches long, the cheaper coil was only 15 inches long. Now that could be a problem depending on how you route your wire, but I think we're going to be good because I know on my generator my ground wire loops around and is tied up with a tie wrap to hold up the slack. So that 15 inches is probably not going to be an issue. The core thickness on the expensive coil was 11.9 and the cheap coil was 12.1. The cores are so close. One was 11.9, one was 12.1, but when I remeasure them, I can get them both to read 12. So when you look at this, this is the expensive coil here, and you can see I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 crimps holding the core together there, where on the cheap one I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the mechanism to hold the core together on the cheap one is not as involved as it is on the expensive one, and so that's telling me that this was a cheaper manufacturing process to build this coil, and that's maybe resulting in the cheaper cost. Okay, and what's the other thing? The center to center between the mounting holes, they were identical. This high tension wire seems more secure in the more expensive coil than it does in the cheaper coil. You know, from physical measurements and observations, there's not a lot of difference between the two of them. So which is the best coil? The $41 one or the $14 one? I don't know. Which one would I put in my generator? I don't know that either, to be honest with you. First off, I was going to say I would put the more expensive coil in because I'm figuring that's going to be better coil. It looks like it's made better. But is it worth, what's this, $14 opposed to $41? So this is like almost a third of the price. I would say I would use the $14 coil, because if I put this in my generator and the power goes out and I'm using my generator and this fails, I have the ability to come here in my shop, check it, test it, and replace it. A $41 one, I'm not convinced that 3 times the price makes this last 3 times as long. And having said that, how reliable is this? If it ever fails, it's as reliable as you can imagine, right? Like you would never lose faith in it if it never fails. The moment it fails, it has no more reliability. So is the reliability of this any better than the reliability of this? That's the big question, right? When I was at work, we were involved with quality assurance a lot. We wanted to make sure that our process met all the ISO standards for right the first time, so on and so forth. So we used to do what was called failure cause and effect analysis on a lot of our equipment. So in other words, if there was a failure, what was the cause of that and what was the effect of that failure? We'd analyze the cause so that we could put in place mechanisms and procedures to prevent that cause and therefore eliminate the failure, because we wanted to have 100% uptime at our facility. So when you do a failure cause and effect analysis, I'm analyzing the cause of why the generator failed. The cause of why the generator failed was it had a bad coil. What can I do to fix that? Coils are basically solid state inanimate objects. So there's nothing in there that we can repair, nothing in there that we can improve. So one thing you could say is, I'm going to put a better coil in place to eliminate that cause or to diminish that cause and prevent my generator from not working. So then, how do we put a better coil in? Do we put a $41 coil in, assuming that it's a better coil? Or do we put a $14 coil in, assuming that the coils are basically all the same? And that becomes the difficult question to answer. I'm going to go in my generator and put the $14 coil in. And I'll keep a record of that. If this one fails, then I'll not get this coil anymore. I'll get the $41 coil. But still, I don't know how long the $41 coil will last. But anyway, that's the way I'm going to go. You can take that for what you want. You can say, hey Mike, you're way off based on that one. You should put the best coil you can, the best parts you can in place. But here I am, going to put a $14 coil in my generator. The other part of the failure cause and effect analysis is, what's the effect of the failure? Well, if I had a generator and the failure was the choke lever broke off, the effect of that is minimal because I can still work the choke maybe by reaching in with my fingers. If a coil fails, the effect of that is serious consequences because my generator now will not go at all. So when you take into account the effect of your failure, then that will also maybe put more spotlight on the cause so that you can make a good solution for the cause, or a better solution for the cause. Again, I come back to the fact that if my generator fails catastrophically, like a bad coil, and it just won't run anymore, I have the ability to take it here in my shop, dismantle it, and analyze it, and install this coil. And I can do that with or without power. I don't, like if my power is out, I can still work in the shop here because the tools are all manual to do this. So the effect of having a coil fail in my generator, because of my ability to make that repair quickly, is less than an effect of a repair or a coil that failed in someone's generator who doesn't have the access to a shop to make their own repairs, right? So when you weigh all that and put it all in here and sleep on it and whatnot, I come up with the fact that if I was doing this for a paying customer, I'd put the $41 coil in, send them away home, and I'd feel good about that. But since I'm going to be doing it for myself, I'm going to put the $14 coil in, because the cause and effect, the remedy to the cause doesn't overrule the effect of the failure, in my book, if you can follow all that. Pretty heavy stuff, eh? But I'm going to put the $14 coil in my generator, and if I have a customer or a friend that wants their generator repaired, I'll put the $41 coil in their generator. That's all I know about that. Thanks for tuning in. I hope you found this interesting. I don't know whether it helps you solving your problems of what parts to buy or not, but anyway, that's what it looks like here. Thanks for watching. Don't forget to click like. Don't forget to subscribe. Don't forget to share. Don't forget to have a good chuckle. And basically, most important, leave some comments. Tell me what you think. Should I put the $41 coil in, or should I put the $14 coil in? That's the $30, $40 to $27 question today. What coil should I use? See you next time on Grampie's Workshop. We'll talk to you.